Today we're going to talk about remainder theorem and some of its uses with polynomials. Remainder theorem uses the process of synthetic division, and then we focus on the remainder to tell us certain things. In the past, we have focused on the remainder to see whether or not a factor or a root is actually a solution to a polynomial. If we got a remainder of 0, it was an answer. And if we got any other remainder, it was not. We're going to take it one step further today. If we are evaluating a function at a given value, instead of looking at whether or not it is a root, we're actually going to be looking at the remainder to give us the other part of this point. Now, this is f of a, which might be confusing. But whatever letter is inside of the parentheses does represent x, and the answer will represent y. So when they give me a equals 3, they're giving me the x value. When I evaluate this function, I will know the y value. In the past, if we were given a value and we wanted to find y, we would simply take this value and plug it in everywhere that we had an a. But you can see when I've got these variables with these exponents, this could be a tedious process. So synthetic division will simplify this for us. When we do synthetic division, we will use the number exactly as it's given to us. Don't change the sign. Make sure that your terms are set up in descending order and that all of them are there. If they are, you can go ahead and write down your coefficients. Let's bring the first term below the line and we'll start the process of synthetic division. All right, so as I said before, the remainder tells us some important information. The first thing that it tells me is this particular point is not a solution to this function. Since this did turn out to be a number and not 0, then I know it does not cross the x-axis at this point. But this is a point on this graph, 3, -10. Another way that you might write this answer is that f of 3 is equal to -10. Let's do one more example just to make sure you got the hang of this. If I want to evaluate this function at -2, I'm going to use the -2 exactly as it's given to me. I'm going to double check my polynomial to make sure it's in descending order and that all my terms are there. In this particular case, I am missing the a squared. So when I write out my coefficients, make sure that you put a 0 where that coefficient would have belonged. So when I write out my coefficients, make sure that you put a 0 where that coefficient would have been. Drop your first term below the line and start your synthetic division. Just like before, this particular value is not a solution to the polynomial. But if I'm wanting to know where the point is on this graph, -2 has a point at there is a point at -2, -3. And just like before, this answer could also be written as f of -2 equals -3.